we are going to continue talking about Newman projections. And we said in the previous video that here we have this molecule that we see is three-dimensional and that we can draw it different ways. So in drawing it with Newman projection is about rotating it like so. And in this case, see, if in the previous drawings, we can do the line, as we said before, and we can also do our 3D using wedges and dashes. And what I'm gonna do this one here. I'm gonna pick what I have on my hand is I have one, say this is ethane, but I'm labeling one of the hydrogens and putting it green. That's it, that's what I'm doing. So that we see how I move the molecules. So in drawing it as it is, I'm holding it by the green, right? So here I have this, and in the plane, I have 1, 2, 3, 4 atoms. So this is that. And then I have one hydrogen is pointing towards me. This is my view. And this is pointing towards the screen, so away from me. So, and this is what so away from me is dashes. Towards me is wedges. And I'm going to do the same here. So the green is what I'm holding it from. And so I have one in and one out. And what I did is then, this is your wedge and dash representation for your 3D. And what we're doing in the Newman is rotating it. So now I have, the way I'm holding it, you don't see the green, is I'm holding it by that, right? And so the Newman representation, you will draw a circle that represents the carbon in the front. And now this is how I see it. So I'm holding it by the green is down, right? So that's that. Let's do something here. I'm just gonna pop this in a different color. That's the green that I have here. I don't know if it's gonna show, so let's do that. So now, this is the view that I have, this carbon atom, see? I'm rotating, is in front of me. That's the hydrogen that I have labeled in green. And then I have one, this one here, two, down one side, the other side. The other carbon, I don't see the bond carbon. All I see is what is attached to it. So I have this hydrogen, the hydrogen, and the hydrogen. And that's one of my Newman conformations. Now, this projection, particular projection, we're going to call staggered. And now, notice that I can, this bond, I can rotate, right? And when I do that now, this is actually right behind. So this conformation is different. And so again, I'm going to put this as my green. I kept the one that I'm holding in the same position. This is the atom I'm looking at, my front view, this one. And then left and right. And now, because I rotated, what I did is this one, I rotated 60 degrees, like that. And then this hydrogen one right behind the other, another right behind, and right behind. And this conformation is called eclipsed. And I can keep moving this. And I will do another stagger, another eclipse. But notice again, this is the same molecule setting. So I got here a little toys to show you what is that projection, what I mean by that. So this is a doggy here, toy. Well, it will be the same. It's the same toy if I look at from this view, or this, or even that view. Or say that I grab this. Well, right now, that would be like my Newman projection. I only see this. But if I rotate it, oh, then I see that. Now I can see two wheels, right? I can see it from the top. I can see it from the bottom. But, you know, it is the same object. Same. So I'm doing with the molecules the same. So conformation is the same molecule. Only what I'm doing is here, coming from here to here is showing you a projection. Another way, instead of saying that you're looking at the molecule like that, no, you're looking at the molecule as is. So in this part is eclipsing the other part. Exactly that. And also I'm saying that you can do a lot of movement here. And in doing that, you get different projections. When you have this, say, alternate, it is called a staggered conformation. And when you rotate this, and now this is right behind, we call those eclipsed conformation. These we're going to be using to do conformational analysis. Yet we need another definition. I said before that I wanted to label, say, that one atom as the green. And now I am going to replace another atom by another color. And so to make another definition here, that definition is the angle between constituents on different carbons. Now here I have, notice the green, and here I have a purple, right there. Notice they're opposite to each other. Now I have purple here up and green here. So as if I had, now this is my green, and I just did this. I tinted that purple. Well, we're going to define dihedral as the angle between this, say, any two, but here, particularly this one, is at 180 degrees. See, if you see this line, this is 180 degrees. So the dihedral angle is the angle between, say, one constituent, something in the front, something in the back. And that right here is 180. That's the dihedral. So that will be important. If I keep rotating that, notice that now they are, see the relative position here, I have purple, and let me change my hand to the other side. Purple and green, they are now at 120 degrees. So these are concepts that we're going to be using to do conformational analysis.